In the world of modern military technology, stealth has long been hailed as the ultimate defense against detection. Stealth aircraft, like the F-22 Raptor and B-21 Raider, rely on their ability to absorb and scatter radar waves, making them nearly invisible to conventional radar systems. But in a world where every edge counts, the quest for the ability to detect these elusive aircraft from space has been a tantalizing dream, until now. In 2022, China launched a game-changing system, the LT-1 dual satellite radar. If it works as advertised, this radar has the potential to fundamentally alter the landscape of aerial warfare by challenging the very idea of stealth. Here's a deeper look at how this innovative technology could upend the balance of air power and why it might soon be a critical tool in detecting even the most advanced stealth aircraft. The dream of space-based detection. For decades, radar technology has been at the heart of air defense. Traditional radars work by sending out radio waves that bounce off objects, with the reflected signal being analyzed to determine the target's position, speed, and other characteristics. Stealth technology, however, was designed with one goal in mind: to minimize the radar cross-section, or RCS, of an aircraft. This reduces its visibility to radar systems, making it harder for enemy forces to detect. But what if radar could operate from space, scanning large swaths of the Earth's surface, including the skies, and see through the clouds, fog, and darkness that traditionally limit detection? For years, this concept seemed virtually impossible due to the limitations of space-based radar technology. The vast distances involved in space-based detection and the immense clutter from the environment made it exceedingly difficult to isolate the faint radar reflections from stealth aircraft. However, China's LT-1 radar system may have cracked the code. The LT-1 dual satellite system. The LT-1 radar system consists of two satellites strategically placed in orbit to work in a B-static configuration. One satellite transmits radar pulses, while the other receives the reflected signals. This method of operation, where the transmitting and receiving antennas are separated by a vast distance, provides a huge advantage over traditional radar systems. By separating the functions of transmitting and receiving, the LT-1 significantly reduces the interference and noise that typically plague space-based radar systems, resulting in much clearer signals. The LT-1 operates in the L-band frequency, which is well known for its ability to penetrate obstacles like clouds, fog, and even light vegetation. This ability to see through environmental clutter gives the LT-1 an edge in detecting objects that would otherwise remain hidden in traditional radar systems. The system's impressive 4-kilowatt transmission power allows it to detect objects moving as slowly as 50 kilometers per hour, even when these objects are coated with radar-absorbing stealth materials. What sets the LT-1 apart is not just the technology, but the rigorous research and simulations conducted by Chinese engineers. The radar system is backed by extensive modeling based on actual radar physics, simulating stealth aircraft with a realistic radar cross-section. The result, it appears that the LT-1 could be capable of detecting stealth aircraft in ways that previous systems couldn't, making what was once invisible, visible. The geometric secret to stealth detection. The breakthrough behind the LT-1 system lies in its approach to radar waves and the geometry of the radar's transmission and reception. In conventional radar detection, stealth technology works by deflecting radar waves coming from a single direction, typically from the ground. Stealth coatings and shapes are carefully designed to scatter radar waves in a way that minimizes their reflection back to the source. This is why stealth aircraft are difficult to detect from traditional radar systems on the ground. But the LT-1 takes a different approach. It operates in a bistatic configuration, with one satellite transmitting and another receiving the signal from a completely different angle. This technique, known as large azimuth bistatic angles, is key to the system's success. By receiving radar waves at a different angle than the one the stealth aircraft is optimized for, the radar's reflection increases, making it easier to detect. Think of it like this: if you shine two flashlights on an object from different angles, it's more likely that the object will be visible in the overlap of the beams. This principle is at the heart of the LT-1 radar's ability to pick up signals that would otherwise vanish into the noise. Overcoming clutter and interference. One of the most challenging aspects of satellite-based radar is dealing with clutter, the unwanted reflections from natural and man-made objects like mountains, oceans, and cities. In conventional radar systems, this clutter can overwhelm the weak signals returned by stealth aircraft. China's engineers have developed a sophisticated radar clutter model to address this issue, which simulates real-world reflections more accurately than anything before it. This allows the LT-1 to filter out irrelevant signals, focusing solely on what is moving, such as an aircraft, and ignoring the static background. Another significant advantage of the LT-1 system is that its receiving satellite does not transmit any signals, making it harder to detect or jam. In electronic warfare, this is a major benefit, as adversaries would have a much more difficult time locating or disrupting the satellite's ability to receive radar signals. This also enhances the radar's survivability in contested environments. The potential strategic impact. If China's LT-1 system proves effective in real-world operations, it could revolutionize how military forces plan their air operations. For decades, stealth technology has been seen as the great equalizer, a way for an aircraft to strike first, unseen and undetected. However, with space-based radar capable of detecting even the most advanced stealth aircraft, this era of invisibility could soon be over. In terms of its operational impact, the LT-1 system could provide continuous, all-weather surveillance, a critical advantage over optical satellites, which are limited by daylight and weather conditions. Unlike optical systems, which can only capture images and are subject to clouds and storms, the LT-1 radar operates 24/7, unaffected by environmental factors like weather or time of day. This makes it ideal for continuous monitoring, early warning systems, and defense applications. The coverage provided by the LT-1 system is another game changer. A single satellite in orbit can cover vast areas, scanning thousands of square kilometers in a single sweep. By combining multiple satellites into a constellation, China could potentially track stealth aircraft, drones, bombers, and even cruise missiles over entire regions, creating a global network capable of monitoring the skies at all times. The skepticism and challenges ahead. Despite the excitement surrounding the LT-1 system, there is skepticism. Many Western analysts point out that simulations, while promising, do not always translate into real-world success. The environment in space is complex, with issues like ionospheric interference, signal attenuation, and precise timing all presenting challenges for effective radar operation. However, China's research suggests that these hurdles are becoming less daunting. Advances in onboard computing, signal processing, and artificial intelligence are making real-time space radar analysis increasingly feasible. If China can overcome the remaining technical hurdles, the LT-1 system could become a powerful tool in global surveillance. The end of stealth. The LT-1 radar system represents more than just a technological breakthrough. It offers a glimpse into the future of global defense. If it can be verified in real-world applications, it could mean the end of the invisible era for aircraft. Stealth technology won't necessarily become obsolete, but the ability to detect stealth aircraft from space would force a reevaluation of how they are used and how future aircraft are designed. The ability to track stealth aircraft, not by breaking their stealth coatings, but by leveraging a different perspective, is the key to the LT-1's potential. It signals a new era in air defense, where space-based surveillance could become as critical as the aircraft themselves in ensuring air superiority. In the race for technological dominance, the quest for invisibility may never truly end. It just moves to a higher plane, where space-based surveillance systems like China's LT-1 could ultimately decide the fate of aerial warfare. As we continue to push the boundaries of technology, one thing is clear: the future of air power is no longer confined to the skies alone. It's reaching for the stars. If you found this video fascinating and want to stay updated on the latest breakthroughs in space technology and military advancements, don't forget to like and subscribe. Also, feel free to drop your thoughts in the comments below. We'd love to hear what you think about China's LT-1 radar system and its potential impact on air power. Thanks for watching, and we'll see you in the next one.